So in this video, we are going to attempt the structured questions that are related to chemical bonding. So first of all, define electronegativity. So what is electronegativity? That is the ability of an atom to attract shared pair of electron in chemical bonding. In covalent bonding, if we specify it, it is going to be covalent bond because sharing of electron always occur in covalent bond. How electronegativity changes across a period? So what happens? Electronegativity in fact increases because electronegativity is dependent on the nuclear charge. So En is basically directly proportional to nuclear charge, and En is basically inversely proportional to atomic radius. So what happens in period? What happens? The atomic radius decreases and the nuclear charge, like what happens? Atomic radius decreases. Why decreases? Why atomic radius decreases across a period? Because of atomic radius first of all decreases. Why it decreases? Because of increase in nuclear charge. What happens? Because of increase in nuclear charge, the electrons, the nucleus is pulling the valence electron with more force of attraction, and it causes atomic radius to be decreased. So electronegativity value in fact increases. Why? Because of increase in nuclear charge, as it is directly proportional increase in nuclear charge, and because of decrease in atomic radius. Now they are saying PCl and SCl are both polar bonds. The electronegativities are given. They are saying identify which bond is more polar. So the more polarity is basically lies on the fact which is going to have greater electronegativity difference. So if we see PCl, its electronegativity difference is going to be 3 minus 2.1, that is 0.9. And if we see the other one is going to be SCl. If we see SCl, then its electronegativity difference is 3 minus 2.5, that is 0.5. So the answer is going to be PCl. Why? Because it has greater electronegativity difference as compared to SCl, which has less electronegativity difference. Then they are saying describe how sodium chloride forms in terms of electron transfer. So what happens? Sodium is 281, its electronic configuration is 281, and chlorine is 287. So what happens? An electron from sodium is transferred to chlorine, and because of this, sodium becomes a cation having 2,8 electronic configuration, and chlorine becomes an anion having 288 electronic configuration. So what happens there? Sodium atom sodium atom lose one electron to form sodium ion, while chlorine atom gains one electron to form chloride ion. Explain why sodium chloride has higher melting point than carbon dioxide. So we are going to see that sodium ion and chloride ion, they form an ionic compound, and uh, as they form ionic compound, there exists a strong electrostatic force of attraction between cations and anion. So there exists strong electrostatic. The other name of electrostatic force of attraction is Coulombic force. Strong electrostatic force of attraction between cations and anions, and because of this they are going to have high melting point than carbon dioxide, and carbon dioxide are going to have weak intermolecular force of attraction. Intermolecular force of attraction. One carbon dioxide molecule and other carbon dioxide molecule, they are going to have weak intermolecular force of attraction. And then what happens afterwards, we can write it here, that NaCl has strong electrostatic force of attraction or Coulombic force of attraction. Coulombic force of attraction, while carbon dioxide has weak intermolecular force of attraction. Then explain how the difference in electronegativity between atoms determine whether bond is ionic or covalent. So if a difference in En value is above 2.0, then it is ionic bond, while if difference in En value is less than 2.0, then it is going to be covalent bond. Then the table below shows the bonds formed in different molecules: hydrogen, hydrogen, oxygen, double bond oxygen, N triple bond N. Identify which bond is the shortest. So you can see the bond order is increasing. The bond order specifies the number of bonds. So you can see it is increasing. Hydrogen is having single bond, oxygen is having double bond, nitrogen is having triple bond. So as the number of bonds are increasing, what happens? The bond length, they are getting shorter. Okay, so basically what we have analyzed, that bond order is inversely proportional to bond length. That means greater the bond length, greater the bond order, smaller will be the bond length. So because of this, we can see one thing, that nitrogen N triple bond N has the shortest bond length. And now they are saying the bond energy of CH bond in methane is 412, while the bond energy of HF is 565. First question is, explain why HF bond has higher bond energy than CH bond. The reason lies in the electronegativity difference. As we know that fluorine is more electronegative than carbon. So what happens, as fluorine is more electronegative than carbon, so there is stronger attraction between bonding electrons and nucleus. Predict whether the bond length in HF is longer or shorter than CH. So we know that HF is having the greater bond energy. Okay, HF is having the greater bond energy. That means its bond is going to be stronger. So HF is having shorter bond length as compared to carbon hydrogen. Then they are saying, explain the type of bonding present in compound X. So this is compound X, and the type of bonding present in compound X, as you can see that all of them are non-metals. So the bonding that is present between non-metals is going to be covalent. So covalent bonding, because all the atoms are non-metals. Then in the next question, they are saying, is the carbon-oxygen bond in compound X non-polar covalent or polar covalent? So carbon-oxygen bond in compound X is polar. Why it is polar? The reason is that because oxygen is more electronegative as compared to carbon, and this causes a dipole because the bonding electrons, this cause a dipole to be established because the bonding electrons are shared unequally. So what happens, like, this is carbon, this is oxygen being more electronegative, so it is going to have partial negative charge, and carbon being less electronegative, so it is going to have partial positive charge. So they are saying in the next question, predict whether compound X is polar or non-polar. It is going to be polar. And why it is polar? Because it contains polar bonds. It contains carbon oxygen bonds, so that makes the whole molecule to be polar. So it contains polar bonds and that are not arranged symmetrically. That are not arranged symmetrically. If they would be symmetrical, then what happens? It will make them as non-polar. Then they are saying in the next question. So in this question, they are saying identify the strongest intermolecular force between molecules of compound X. So the strongest intermolecular force is going to be hydrogen bonding because of the presence of OH group there. There is hydrogen bonding which is going to be the strongest force, strongest intermolecular force that comes from the OH group. And what happens because of that? These strong forces, what they tends to do, these strong forces hold the molecules tightly, hold the molecules tightly and in the solid form, in the solid, so that more energy is required to overcome them, to overcome them, and because of that resulting in higher melting point. Then they are saying why compound X dissolves readily in water. We have discussed thing that compound X is polar because of presence of carbon double bond with oxygen, and water is also polar. And the simple rule is like dissolves in like. As compound X, as compound X and water are polar, so what happens? So they can form hydrogen bond. They can form hydrogen bond with water. So in the next question, they are saying two substances C2H6 and methanol are both gases at room temperature and having different physical properties. Based on E and difference, classify the bond between carbon and hydrogen. So carbon and hydrogen, they have electronegativity difference of about 0.4. So what happens because of that? It is going to be non-polar. It is going to be non-polar as difference in electronegativity value is small. Then identify the strongest type of intermolecular force that is present between molecule of C2H6 and CH3OH. So C2H6 is going to have the London dispersion force, or we can also call this as um induced forces as well. So because of the presence of OH group in CH3OH, it is going to have hydrogen bonding. So in this question, they ask us to draw the Lewis diagram for CH3OH, and if we want to draw Lewis diagram for this one, it is going to be oxygen having lone pairs on it, that is going to be with hydrogen. So this is the Lewis structure. Then we have draw a diagram to show the intermolecular force between two methanol. We know the intermolecular force that is present between two methanol is going to be hydrogen bonding. And how we can show them? That this is methanol having oxygen, lone pair of oxygen there with hydrogen, and this is having partial positive charge while this have partial negative charge. It is going to develop a force of attraction with another oxygen that must need to have lone pair. Remember, hydrogen bonding is developed between hydrogen, and the other should be the most electronegative element, that should be either oxygen, fluorine, or nitrogen. So it develops with the lone pair on the most electronegative element, and this is a way we can show its hydrogen bonding. So in the next question they are saying that why the boiling point of CH3OH is significantly higher than that of C2H6. The reason is because of stronger intermolecular force in CH3OH, that is hydrogen bonding. So intermolecular force in CH3OH are stronger than C2H6. This means more energy is needed to overcome stronger attraction. Now the last question is, they are saying methanol is highly soluble in water while ethane is nearly insoluble. Explain the difference in solubility in terms of molecule polarity and interaction with water. So we know CH3OH methanol is polar and forms hydrogen bonding with water, while C2H6 it is non-polar and cannot form favorable interactions with water. So non-polar molecule basically they don't dissolve in water.